Good morning, students. Today we will start with a new chapter. So the chapter name is Atoms. Right? So from this chapter, for board exam, we have the weightage. Right. From this chapter for board exam, we have 5 marks. Right? So this chapter is also for the 5 marks. So from this 5 marks, we have directly one question for a long answer, that is for 5 marks. Either this long question either may be come from the numerical part or from the long answer part. So this chapter has 5 marks. So this 5 marks will have only one question, either the derivation or it may come from numerical part. So in the rare cases, so this 5 part will divided one question for 3 marks and one question for 2 marks. Right? So this is about the weightage of the marks. Directly one question they ask for the 5 marks. So either it may come from theory part or it may come from the numerical part. So in the rare cases they ask the one question for 3 marks. Right? So this is about the weightage of this chapter atoms. So as already we have studied from the lower classes, that is atoms. Right? So here in this chapter we will go in deep with the chapter, that is regarding about the atoms, right? So first, what are atoms? So before going to atom, so what is matter? So matter is anything that will occupies the space, right? So if we divide this matter into small particles, then we get the elements. Then we divide the elements into further, then we get the final, that one is atoms, right? So we can further divide atoms. So now we can also further divide atoms, and but these atoms have the characteristics which have the same characteristics of this element. If we further divide atoms into smaller particles, so those smaller particles will not have the characteristics of the elements, right? So atoms are the smallest unit of the matter which has the same characteristics of the elements, right? So if we further divide the atoms into smallest particles, so those particles will not exhibit the characteristics of the elements. So only atoms will exhibit the same characteristics of the elements, right? So hence atoms are the basic units of the matter, right? So if we define atom is the basic unit of the matter and it defines the elements, that is characteristics of the elements, right? So it gives the properties of the elements because elements have the same properties as that of the atoms, right? For that reason, so atoms are the basic units of the matter. So if we define atom is the basic unit of the matter and it defines the structure of the elements because these two have the same characteristics, hence it defines the structure of elements, right? So if we define atom, so atoms are the basic units or basic unit of the matter and defining and define the properties or characteristics of element. Or we can say this one as define the structure of element. Directly we say define the structure of element. So this is the definition of the atom. So definition is atom is the basic unit of the matter. So matter is the anything which occupies the space and it has some mass. Then only we can say that one is the matter. So if we divide the matter, then we get the element. So if we further divide the elements, we get the atoms. So the atoms has the characteristics or properties has the same as that of the element. So from that, if we define, we get atoms are the basic unit of the matter and defining the structure of the element. Right. So this is the definition of the atom. Next, atom model. So what is atom model? So here we already studied the atom. So what is the atom model? So any model which gives the structure of the atom and it explains the characteristics of the atom, then that model we call as atom model. So any model which gives the structure of atom and it explains the characteristics or properties of the atom. Right? So that model we call as atom model. Right? So atom model is any model which can use the structure or it can explain the structure of the atom and also the characteristics of the atom. Then that model we call as atom model. So the first atom model was proposed by J.J. Thompson. Right? So the first atom model was proposed by the scientist named that is J.J. Thompson. So in this chapter we are going to discuss about on this atom model. So in our syllabus we have 3 atom models, that is 3 types of the atom models. So in this chapter we will discuss in detail on these 3 atom models. So what is atom model? So atom model is the any model which gives the or which explains the structure of the atom. Structure is how atom is in exhibits. So how is the nature of the atom, right? So these are the 2 points. If any model which explains these 2 points, then that model will say that as the atom model. That is any model which can explain the structure of atom and also the characteristics of the atom. Right? So the first atom model was proposed by the scientist that is J.J. Thompson. So in this chapter we have 3 types of atom model. Right? So those 3 types of atom models are types of atom models. So first one is Thompson atom model and second one is Rutherford atom model and the third one is Bohr's atom model. Right? So these are we have total 7 to 8 atom models. So out of those atom models, in this chapter we are discussing the 3 atom models. That is Thomson's atom model. That is the first atom model which was proposed by the J.J. Thompson. Hence the name is given as Thomson atom model. So later the Rutherford proposed the atom model. That is Rutherford atom model, and after that Bohr's atom model. Right? So in this chapter we will discuss about these 3 models. Right? So if we start with the Thompson atom model. So that one is the first atom model which was proposed by J.J. Thompson. So So this one is the first auto model which was proposed by the Thompson. So according to this model, the total positive charges of the atom are uniformly distributed in a atom, and the negative charges, that is electrons, are like they are present in the manner of the seeds which are presenting in the watermelon. So right, so the Thompson given the auto model is that the total number of the positive charges in an atom are uniformly distributed throughout the volume of the atom, and the negative charged electrons are embedded in a seed-like forms in a fruit, right? That is the watermelon fruit, right? So that is given by the Thompson, right? So according to this model, the positive charges are uniformly distributed the positive charges of the atom is uniformly distributed throughout the volume of atom and negative charge electrons and or embedded negative charge electrons are embedded in it like seeds in watermelon, right? So this one is the model that was given by the Thompson. So according to this model, right, the positive charges of the atom. So if we consider this one is one atom, right? This one is the atom. It is in spherical shape, right? So the positive charges are uniformly distributed in this, right? So these positive charges are uniformly distributed throughout the volume of this sphere, right? Like this. So these are the positive charges which are uniformly distributed throughout the sphere, that is in the atom. Next, the negative charged electrons, right? So the negative charged electrons are present in this atom in such a manner that the seeds which are presenting in the watermelon fruit, right? So somewhere here randomly the electrons are present, that is minus represents the electrons, negatively charged particles, or these are the electrons, right? So he compared this one with the watermelon fruit, right? So in the watermelon fruit we have the red color which is edible part, right? So if you consider this one is like the watermelon, so these red color represents what? The positive charges, right? So if you consider this one as the watermelon fruit, right? So outer part is covered with the green, so inside we have the red edible part. So in that red edible part, so this red edible part represents what? The positive charges, right? So the entire positive charges are uniformly distributed. So next, the seeds which are present in this watermelon, right? In the watermelon fruits, the seeds are present like this. So he tells that these seeds which are present in the watermelon, which represents the negative charge, right? So the edible part is, that is, which is edible part. So that part is positively charged, and the seeds which are present in this watermelon, that will equals to the negative charge. So this one is given by the Thompson. So the first model which is explained by the Thompson is compared to that of the watermelon, right? So in this model, the positive charges are of the atom, that is positive charges in the atom, is uniformly distributed throughout the volume of this atom. So atom is in the spherical shape. Throughout this volume, it is in spherical shape. So throughout this volume, the charges are, positive charges are uniformly distributed, right? So the electrons are which are present in between these positive charges. So those electrons are indicates that the, that is, he compared with the seeds which are present in the watermelon fruit. So positive charges he compared with the edible part, so which we are eating, the red color part. So that part he compared to that of the positive charges, and the negative part is compared to that of the seeds which are present in the watermelon fruit. Right? So this one is the first atom model that was given by the Thompson. Right? So according to this model, the positive charge of the atom is uniformly distributed throughout the volume of the atom. So throughout this volume, the charges is positive charges, right? So the negative charges are electrons. So negative charges we call that one as the electrons. So those electrons are embedded in it like the seeds in the watermelon, right? So this one is the Thompson model, right? Next, so this Thompson model is also given the name, that is plum pudding model. So this given this one name as plum pudding model, right? So plum pudding is nothing but the dry fruits which are present in one edible part, right? So if you compare any one of the cake, so in that cake they are arranged the dry fruits, right? So those dry fruits is compared with the negatively charged electrons, and the cake which is made, so those are the positive charges. So this model we call that one as plum pudding model. The dry fruits which represents the negatively charged particles, and the whole edible part of the cake, that is dry fruits also edible, but here the cake has the maximum quantity, so that one is compared with the positive charges. So hence they given the Thompson model as the name plum pudding model, right? Next, the limitations of this model or drawbacks of this model. So what are the drawbacks of the Thompson's atom model? So Thompson's atom model cannot explain how the positive charges will hold the negative charges inside the atom, right? So he can't explain why these positive charges, how they bind with the negative charged electrons, that is how they hold the negative electrons inside this atom, right? So that one is the first drawback. So Thomson unable to explain how the positive charges encloses the negative charges inside the atom. So that one is the first drawback, and the second drawback is he can't able to explain the stability of this atom, right? So those are the two drawbacks of the Thomson's atom model, right? So in that first one, so Thompson's model fails to explain how positive charge holds electrons inside the atom. Right? So this one is the first drawback. So the first drawback is it fails to explain how the positive charge holds the electron inside the atom. Right? So next, the second drawback is fails to explain the stability of atom. Right? So these are the two drawbacks. So the first drawback is it fails to explain how these positive electrons holds the negative electrons inside the atom. That is, atom is in sphere. So if we consider that one in the sphere, means it can't able to hold the electrons inside the sphere. Right? So here the Thompson says that the electrons are which are present inside the atom, that is in the positively charged particles, that is with the positive charges the electrons are present inside the atom, right? So that one is the first drawback, and the second drawback is the Thompson model unable to explain the stability of this atom, right? So these are the two drawbacks of the Thompson's atom model. So this is about the first atom model which was proposed by the Thompson, right? So move on to the second one. So second one is Rutherford atom model, right? So according to this model, the entire positive charges and the mass of the atom is concentrated at the small volume. So that volume we call as the nucleus, and the electrons are revolving around the nucleus. So that as like the planets which are revolving around the sun. So this one is given by the Rutherford. So the Rutherford atom model is the entire positive charge and the total mass is concentrated to the small volume. So that one we call as the nucleus, and the electrons which are revolving around the nucleus as the planets revolving around the sun. So this one is given by the Rutherford. Hence the Rutherford atom model is also named as the planetary atom model. So that one is given by the Rutherford. So according to the Rutherford, the entire positive charges and the total mass of the atom are that is concentrated to a smaller volume. So that volume we call as the nucleus, right? So that volume we call as the nucleus, and the electrons revolving, that is negatively charged particles which are revolving around that nucleus, right? So as like of the planets which are revolving around the sun. So hence the Rutherford atom model is also named as planetary atom model, right? So from this theory, from this Rutherford atom model, he gives that the theory of the nucleus. Hence this model is also called nuclear atom model, right? So here they given the two names. So one is the planetary atom model because the electrons will revolve around the nucleus as like the planets which are revolving around the sun. Hence the model name given as planetary atom model. And the first time the nucleus concept was introduced by the Rutherford in this atom model. Hence they given that one as the nuclear atom model. Right? So the entire positive, the statement is according to this model, the entire positive charge and mass of the atom is concentrated in a small volume called nucleus, and electrons are revolving around the nucleus as like planets revolving around the sun. Right? For this reason, the Rutherford atom model is named as the planetary atom model. Right? So, according to this theory, the total number of positive charges, and so if we consider this one as one atom, so in this atom we have the positive charges, and so atom is also having the mass. So the positive charges in the atom and also the mass of the atom are concentrated to a smaller value. So these are the positive charges, and it includes the mass of this atom. So this smaller volume, right? So this smaller volume, he called that one as the nucleus, right? So in the atom, so this one is the atom. So in this atom, the positive charges. So here we have the positive charges like this. Right? So these positive charges and the mass of this atom are concentrated, that is they are shrinking to a smaller value. They are concentrated, that is concentrated nothing but one to each other. They are at a nearer distance. So each positive charges are very close. Then it becomes the total mass, and the positive charges are concentrated to the nearer, then it becomes the smaller volume. So if you observe the difference in these two, so here the atom is in the bigger size and here the nucleus is in the smaller size, that is the volume. It is also in spherical shape, so this volume is concentrated, that is its volume reduces because the total mass and the positive charges are shrinked, that is concentrated. So hence that part he called that one as the nucleus, and the electron which revolving around this nucleus, that is the negative charge. So this one is the electron. So this electron is revolving around this nucleus, right? So now this atom is equals to, here we compare means the same size, but here the mass is concentrated. So that part we call that one as the nucleus, and the negatively charged electron is revolving around this nucleus as like the planets which are revolving around the sun, right? So if we have two or more electrons, then it will revolve like this, right? So this complete model was given by the Rutherford. So the first time the concept of the nucleus. So this one is the nucleus. So this nucleus was given by the Rutherford. For that reason, the atom model, that is Rutherford atom model, named as the nuclear atom model. Right? So that is in that nucleus, most of the mass of the atom, that is maximum mass of the atom, and the positive charges are concentrated to a smaller volume. So that means the nucleus consists of the positive charges, right, and also the mass of the atom, right. So in the remaining space is almost empty, right. That is, if you observe here there are no charges. That is, here they have the empty mass. So if you consider here this one as the nucleus, right? So if this is the nucleus, then the electrons are revolving around this nucleus. Then if you observe here, there will be no region. So this region is almost empty region, right? So the electrons which are revolving, so in between the nucleus and the electron, there is the empty space, right? So this is given by the Rutherford. The first time he introduced the concept of the nucleus, right? From that, the another model, that is post-atom model, is also discussed on the model that regarding the Rutherford atom model. So here also we face few drawbacks in the Rutherford atom model. Hence, to overcome that drawbacks, the Bohr conducted the experiment. Then he give the model. That one is the Bohr's atom model, right? So Rutherford conducted one experiment. So the experiment is Rutherford alpha scattering experiment. So this experiment is conducted to prove the theory which was given by the Rutherford, that is the nucleus and the electron, right? So by conducting this experiment, that is alpha scattering experiment, so he proves that the existence of the nucleus and also the electron which are revolving around the nucleus, right? So in the next class we will discuss the alpha scattering experiment and the observations which he did by the Rutherford, right? So in this class, so what are atoms? So atoms are the basic units of the matter and it defines the structure of the elements. So further we can't divide the atoms. If we divide the atoms, that will not exhibit the characteristics of the element, right? So atom model is any model which exhibits the or which gives the structure of the atom and it gives the characteristics of the atom, then that model we call as the atom model. So here we have the three atom models, that is Thompson's atom model, or the other name they given as plum pudding atom model, and the second one is Thompson's atom model. So in the Thompson's atom model they given the name planetary atom model or the nuclear atom model. The reason because the electron revolves around the nucleus, hence for that reason that is similar to the planets which are revolving around the sun. That's why the name given as the planetary atom model. The first time the concept of the nucleus was introduced by the Rutherford in his experiment, hence they given the model name as nuclear atom model. So according to this Rutherford atom model, the entire positive charge and mass of the electron are concentrated to a smaller volume. So that volume we call as the nucleus, and the negatively charged particles, that is the electrons which are revolving around the nucleus, as like the planets, right? So this one is the statement given by the Rutherford atom model, right? So for 3 marks they may ask for the use the theory of the Rutherford atom model or give the postulates or give the observations of the alpha scattering experiment, right? So from here the main concepts will start, that is Rutherford atom model and the Bohr's atom model. So Thompson's model is the first model which explains the structure of the atom. So it has few drawbacks. Hence, we start to follow the Rutherford atom model. Right? So in the next class, we will discuss the concept that is alpha scattering experiment. Right? Thank you.